Hello friends, welcome to this video on physics of car collision. Today I am going to elaborate on a simple principles of physics that we have already learned in school to understand a very real and a serious concern, the physics of car collision. I am Dr. Shyamkant Anwane, Professor and Head Department of Physics, and I will be referring to the Fundamentals of Physics book by Halliday, Rusnick and Walker. The sun is warm, the road is clear, and you are traveling at the speed 60 km per hour with your favorite song on the radio. Everything feels perfectly in control, a symbol of precision engineering and human skill. You are an object in motion, a mass with a velocity possessing certain undeniable momentum. But then, in an instant, a different kind of reality intrudes, a split second decision, a moment of distraction, and suddenly the world rushes towards a catastrophic halt. Two masses are now on a collision course. In the fleeting, terrifying moment, what happens? We shall try to unfold from physics parameters. Today we will dissect the split of second. We will delve into the titanic forces that turns the solid metal into crumbled garbage. We'll trace the path of energy as it vanishes from motion only to reappear as twisted steel and screaming friction. We will measure the immense work done on the cars and their occupants. And we will understand the concept of impulse, a force so powerful that it can shatter bones or even kill the people. If we are clear, be managed over a longer collision time to save life, because in this final dramatic act, physics is not just to observe, it is the ultimate choreographer. Here you can see the time-lapse sequence of collision which is captured by Crash Lab. Here we shall consider a car of mass 1500 kgs moving with velocity 60 km per hour with a bonnet length of 1 meter. So the input data we have to convert into SI system. 60 kilometer, kilo means 1000 meters in 1 hour. 1 hour is composed of 60 minutes each of 60 seconds, that results into 16.67 meter per second. The mass of the car is 1500 kg, that is 1.5 metric ton, and the distance that is cut in collision is about 1 meter for our simplicity in calculations. Now, very quickly, we shall roll through some principles and definitions that we have learned in school time. Linear momentum we define by P. It is product of mass into velocity. Here, mass is in kilograms and velocity is in meters per second instead of kilometer per hour. The Newton's second law states that the rate of change of momentum is directly proportional to the force. So, momentum we can replace by mass into velocity, and we can take out mass out of differentiation sign, and it is dv by dt m times. So it is mass into acceleration, and in SI unit we can write that as kg meter per second square. Now the kinetic energy, everyone knows it is 1 by 2 mv square, and work done when we want to find, so we'll have to find the difference of kinetic energy in the final state minus initial state. That will be work done. And this work done in terms of gravitation, we write as F dot dr, or you can simply consider force into displacement, that is taken care of in our representation. The most important parameter here is impulse, that is change in momentum. So I'm rewriting the expression for impulse as change in momentum delta p, which is equal to f times delta t. So delta t is very small, for small time it is happening, and the involved force is very, very large, and this quantity we call impulse. If you want to learn these things in detail, I have a separate video which I have carried out for physics students. I am going to provide you link of those videos in the description box. Then G force. G force is the force which is in terms of the gravitational force. So acceleration due to gravity G, which is 9.8, if you divide by any given force, it will be offering you G force. We need to give input parameters like mass, velocity, and calculate momentum, force, kinetic energy, work done, involved force, impulse, and duration of collision. So mass is to be used in kilograms, whereas velocity, instead of kilometer per hour, we have to use meter per second. So here multiplying factor 1000 meter in 1 hour, that is 3600 seconds, will be 0.2778. Momentum and force we have to calculate. Kinetic energy will be 1 by 2 mv square. Work done will be final kinetic energy minus initial kinetic energy. Involved force we can calculate, that is change in kinetic energy divided by the distance that it is tracing back. So here you have to understand that about 1 meter distance we are considering this, which after collision we are retrogradating to reach to the passenger. Impulse, which is change in momentum, that is force into the duration of collision, and duration of collision we can calculate from impulse upon force. So let us do that for a couple of situations. We shall consider the collision of car with a wall at the speed of 60 km per hour. We need to key in mass and velocity and find out momentum, kinetic energy, work done, involved force, impulse, and collision duration. Mass is 1500 kg. Velocity of car 60 km per hour turns to be 16.67 meter per second. Momentum will be 25,000 kg meter per second. Kinetic energy will be 1 by 2 mv square when we plug in mass 1500 and velocity square 16.67 square. This turns out to be the kinetic energy 208 kilojoules. Work done is change in kinetic energy, that is final kinetic energy minus initial kinetic energy. After collision car stops, so final kinetic energy is zero. So work done is negative in the sense that work is done against the car by the wall, and that energy, that work done, which has unit of energy, is 2.08 into 10 power 5 joules. So the involved force from the mechanics rule, work done equal to F dot dr, we can calculate force, that is work upon dr. The bonnet size we have considered 1 meter, so work done divided by unity will be that number itself, that will be the force in Newton. So 208 metric ton force will be created on the objects inside the car including the passenger. And from impulse formula, which is change in momentum, we can calculate the collision time. So change in momentum, we already know that car is coming to halt after collision, and the initial momentum was 25,000 and final momentum is 0. So change in momentum is 25,000 divided by the force involved, 2.08 into 10 power 5 Newton. So this offers collision time of 120 milliseconds, very short duration. Now we shall compare the similar data with 120 kilometer per hour speed, and then we will compare and comment. Before that, the acceleration involved, which is according to Newton's second law, force upon mass, we already know force, that is 208,146 Newton divided by mass of the car including passengers. This turns out to be the acceleration of 138.8. If we divide this number by acceleration due to gravity, that is 9.8 meter per second square, the acceleration, which is called g force, that is 14g. So 14 times the gravitational force will come into picture on the passengers. Now consider a car traveling with 120 km per hour collides with a wall, or you can simply consider collision of two cars traveling in opposite direction with the speed of 60 km per hour each. In that situation, we have to plug in the mass velocity of the car with bonnet size and calculate momentum, kinetic energy, work done, involved force and impulse, and we can calculate the duration of collision. That is a very important parameter I am going to highlight later on. Mass of the car, same we are considering, and 120 km per hour can be converted into 33.33 meter per second. The corresponding momentum will be about 50,000 kg per meter second, and kinetic energy 1 by 2 mv square will be 1 by 2 times 1500 into 33.33 square. That turns out to be 833 joules, huge amount of energy. And work done will be change in kinetic energy, that is final kinetic energy minus initial kinetic energy. So minus sign appearing here, this is 8.3 into 10 power 5 joules. The involved force from gravitational potential, we can find W is equal to force into displacement. So force will be work done upon the displacement. dr being unit, work done itself will be with the unit Newton. So 833 metric ton force, a huge amount of force, will be thrashed on the elements inside the car, including passengers. Impulse, which is change in momentum, that is product of huge force and small duration of collision. And duration of collision we can calculate from change in momentum upon force. Car is coming to halt, so final momentum is 0 minus initial momentum, this about 50,000 kg meter per second we have used, and the duration of collision is extremely small, that is 0.06 seconds, that is 60 milliseconds. This is actually a game changer. And if you like to find acceleration, it is force upon mass that comes from Newton's second law. This turns out to be 555 meter per second square when divided by acceleration due to gravity, that is 9.8 meter per second square. This turns out to be 57 g force. 57 times the gravitational force will come into picture that is capable of breaking any human body, and the accident can be fatal. Let us compare these two conclusions. So here we shall compare mass, velocity, momentum, kinetic energy, work done, involved force, g force, and duration for both the cases of accidents. One at the speed of 60 km per hour in this column and 120 km per hour in this column. We have not changed mass of the car, velocity we have doubled. By doubling the velocity, the momentum becomes double. Kinetic energy becomes 4 times, and work done is also 4 times. Involved force is also 4 times, 200 metric ton versus 800 metric tons. These are immense forces. To put it in a perspective, a force of 200 metric tons is equivalent to the weight of roughly 200 small cars. A force of 800 metric tons is yet 4 times more. And G force, if we talk about 14 G force, is quite a strong force that can kill person, but there are chances of survival in case of this speed of 60 kilometer per hour, whereas 57 G force will kill a person. So this speed of 120 kilometer impact, either by collision on the wall or due to collision between two cars of 60 kilometer per hour each traveling in opposite direction. So the duration of collision is very, very important as regards to impulse. And practically, this collision duration is increased so that the impulse is little small, force will be little small. For that, airbags are used, and that slows down, that increases the time duration of collision, and it reduces the impulse and the force. Actually, when we drop an egg from 1 meter height on the floor, the egg will break. But if we allow the egg to fall on sponge of sufficient thickness, then egg may not break because the collision time on the ground is extremely small, whereas due to sponge the collision time increases. So that is the philosophy. Modern cars uses combination of active and passive safety features to include the occupants in the crash and increasingly to prevent accidents from happening in the first place. The active features work to prevent an accident before it occurs. They use sensors, cameras, and sometimes radars to monitor cars' surrounding and a driver's behavior. They are part of what is known as Advanced Driver Assistance System, ADAS. Automatic Emergency Braking System, that is AEB. This system detects potential forward collision with another vehicle, pedestrian, or cyclist. If the driver does not respond in time, the system will automatically apply brakes to avoid or mitigate crash. Lane Keeping Assistance, LKA. This feature uses cameras to monitor the car's position within its lane. If it detects that the car is unintentionally drifting, it can provide an alert or even gently steer the vehicle back into the center of the lane. Blind spot monitoring. Sensors in the car's rear bumper detect vehicles in the driver's blind spot. An indicator light on the side of the mirror or a warning sound alert is given to the driver to avoid the danger. Adaptive Cruise Control, ACC. The evolution of standard cruise control, ACC, uses sensors to maintain a safe preset distance from the car in front, automatically adjusting speed as needed. Electronic Stability Control, ESC. This system helps a driver to maintain control of vehicles during extreme steering maneuvers, such as swerving to avoid an obstacle. This works selectively applying the brakes to avoid wheels to prevent skidding and loss of control. Active safety features is a costly affair and that is available in high-end cars which everyone is not affording. There is a list of passive safety control features. The passive safety features come into play during and immediately after a crash to minimize the injury of the occupants. Airbags rapidly inflate upon impact to cushion the occupants and prevent them from hitting hard surfaces inside the vehicle. Moreover, it increases the collision time so that the involved forces become smaller and the collision time becomes bigger. So the modern cars have multiple airbags including frontal, side and curtain airbags. The most fundamental safety feature seat belts are designed to hold the occupants securely in their seat, preventing them from being thrown from the vehicle or into the interior during the collision. The modern seat belts often have pre-tensioners that tighten the belt in the crash and force limiters to reduce the risk of chest injury. Crumple zones, these are the especially designed areas in the front and rear of the car's body that are meant to deform and absorb energy of their impact by absorbing force. They help keep the passenger's compartment intact and reduce the impact on the occupants. I hope that you have enjoyed this discussion, and if you have any doubt or any say, you can just write in your comment box. Thank you very much.